Hi, Paramanand Ashok Pawar, working as an assistant professor in Electrical Engineering Department, NB Navle, Sinhakad College of Engineering, Solapur. I have completed my BE from Government College of Engineering, Jalgaon, and MTech from TIT Bhopal in a power system. Now I am currently having the teaching experience of 8 years. Today we are dealing with the topic that is parallel operation of alternator. Sometime it is called as synchronization of alternator. So for the operation of synchronization of alternator, will require two type of alternator, that is generator 1 and generator 2, for supplying a common load. One is a running machine and another is a synchronous machine. So let's start. What do you mean by the synchronization of alternator? The process of connecting an alternator in parallel with another alternator or with the common bus bar is called as synchronization. Means the process of connecting one alternator to the another alternator is called as a parallel operation of alternator. So there are basically three methods of parallel operation of alternators are there. First one is called as three dark lamp method. Second one is called as, that is, two dark, one bright lamp method, and third one is called as the Synchronous Scope method. So we'll start the first type of method for understanding of a synchronization of alternator. But before we going to start the synchronization of alternator, if you want to do the synchronization, there should be a various condition for the synchronizing. So the condition for the synchronizing are: the source must have equal, first that is line voltage, second that is frequency, third one that is phase sequence, fourth one that is phase angle, fifth one that is waveform of the system which has to be synchronized with a previous one. So these are the various conditions of the synchronizing of a alternator. Basically the waveform and phase sequence are fixed by the construction of alternator, so its connection to the system. So the voltage, frequency and phase angle must be controlled each time to generate, so is to be connected a grid. So these are the various conditions of synchronizing of alternator. That is the condition number first, they must have the same the output voltage rating. The second, that is speed should be same with a frequency, that is frequency should be same. The third one is a same waveform, but it should be a different kVA rating, no problem, but the waveform should be the same. Then the fourth, that is the alternator has same speed load characteristics. The fifth one, that the alternator should have the reactance in their armature, so otherwise they will not be operate in a parallel successfully. And the last condition for the parallel operation of alternator is the phase sequence of that particular alternator should be the same. So let's start the first method of synchronization of alternator, and that is called as three dark lamp method. So as shown in figure, there is a three-phase supply available for us, that is RYB. So the figure shows an alternator, that is A supplying a load with alternator B all wired up and ready for startup. If these are low voltage generators, the generator B can be phased out by connecting three lamps across the ends of triple pole paralleling switch as shown. So the prime mover of the incoming alternator, that is B, is started and brought up close to the rated speed. That is, the alternator is the excited and the voltage is raised by the increasing the excitation to that of the running alternator or the bus bar. Lamps are watched carefully. If the incoming alternator B is properly connected, all the lamps are become bright and dim together. If the bright and dim in sequence, it shows that the incoming alternator B is not properly connected with bus bars, and the phase sequence of incoming alternator B therefore must be reverse relative to the system. once the alternator B has properly phased out, it will always be correct unless the wiring of the system. So this is a 3 dark lamp method for a synchronization. So as shown in figure, there is a 3-phase supply, that is RYB, the alternator A, the alternator B. So the alternator phase sequence, that is R dash, Y dash, B dash, this is shortened by a switch. So the alternator B, which has a 3 pole, that is triple pole switch, which is connected 3 lamps, that is L1, L3. For the measurement of voltage, we can connect a voltmeter across to any phases of alternator. So basically the lamp L1 is connected to the R dash, lamp L2 is connected to the Y dash, lamp L3 is connected to the B dash. So this is 3 dark lamp method. So if the phase sequence is okay, then these lamps are starting, that is bright simultaneously and dark simultaneously. So the phase sequence remaining the same. If the phase sequence is not same, then the darken, that is flickering, is occur. So that time this method of synchronization is not properly done. So there are different disadvantages of this method. So first disadvantages is that lamps go dark at somewhat less than their 50% rated voltage, and so that the paralleling switch might be closed when there is a considerable phase difference between the machines with a higher circulating current, result in possible damage to the machine. So this is the first disadvantage. The second, the lamp flickers, that is lamp filaments might burnt out for this reason. So it is desirable to have two frequencies nearly equal so that the synchronizing is not dependent on the constant dark period. And the third disadvantage of this method is that the flicker of lamps doesn't indicate whether the incoming alternator slow or fast. So these are the different disadvantages of this method. So that's why the another method is employed, and that method is called as 2 bright and 1 dark lamp method. So the disadvantage of 3 dark lamp method are eliminated in this method, that is 2 bright and 1 dark lamp method, in which 2 of lamps are cross connected as shown in a alternator C. So as shown in figure, there is a connection of alternator, and that alternator is called as alternator C, which is connected to the bus bars for a synchronizing. So as shown in figure, again there is a phase sequence RYB, the alternator which has to be synchronized connected to the load, that is A, which has a phase sequence, that is R dash, Y dash, B dash, and the alternator C is connected to that particular bus bar. But consider that in which here the 2 of the lamps are cross connected. Again there is a phase sequence. For measurement of voltage, we are connecting 1 voltmeter across the 2 phases. So here is a triple pole switch, but the difference in previous method and that method is that in that method we are connecting 2 lamps, that is cross connected. So as shown in figure, there is lamp N1, L2 and L3. So we are connecting, that is lamp L1 and L3 are cross connected, and lamp L2 is connected as it is, that is for the phase sequence B. So as shown in figure, the lamp L1, the first terminal is connected to R dash and the second terminal is connected to the Y dash. Okay, and the second lamp, both connections, that is connected to the B dash, and the L3 lamps, the first connection is connected to the R dash and second connection is connection to the, that is Y dash. So the lamp L1 and L3 are cross connected to each other, and that is the change in previous method and this method of synchronization of a alternator. So let's start. When the incoming alternator is in synchronism with the alternator A, the lamps L1 and L3 are bright and L2 is dark. Since near the point of synchronism, the brightness of one lamp increases and the other decreases, so the instant at which incoming machine is in synchronism with the bus bars can accurately determine, and paralleling switch should be closed at this instant. Let the voltages star, that is RYB, refer to a bus bar. So the voltages, that is R dash, Y dash, B dash, to the incoming machine, that is C. The instantaneous voltage across three lamps are given by the phase sequence, that is RY dash, that is R dash Y, B dash. When the frequency of incoming alternator is the same as that of bus bar, both these rotate in a space with a same angular velocity. So the potential difference across each lamp remains constant. So this method is called as a two bright and one dark lamp method for synchronization. Okay, so let's start the last method, which is very popular for the synchronization of alternator, and most of the time in industry and day-to-day life this method is very useful. So this method is called as a synchronous scope or synchronous scope. So a synchronous scope is a device which shows the correct instant of closing the synchronizing switch. The synchronous scope has a pointer which rotates on the dial. The pointer rotates anti-clockwise if the machine is running slower, or it rotates clockwise if the machine is running fast. The correct instant of closing synchronizing switch is when the pointer is a straight line upward. So as shown in figure, there is a phase sequence, that is RYB, in which the alternator, that is the winding of alternator, is connected here. Again, here is a triple pole switch is there, and here the left hand side there is a one device which is called as synchronous scope. So if the synchronous scope has its pointer at middle side, the pointer is rotated on the dial basically anti-clockwise, then we are saying that the machine is running slower. If the synchronous scope's pointer is rotates in a clockwise direction, then we say that the machine is faster. So we cannot synchronize it. If the pointer shows the straight upwards, so this is the correct instant where the synchronization of alternator should be done. So this is the third device which is used for synchronizing of alternator, and this is very popular method in day-to-day life, which is called as using synchronous scope. So these are the different methods which are used for parallel operation of alternator. So the first method, again, it is called as the three dark lamp method. The second method is called as two bright and one dark lamp method, and the third very popular method, that is using synchronous scope for the parallel operation of alternator. Thank you very much.